Welcome back once again to our Busy channel. So in today's video, we continue our discussion on forecasting by looking at what is quantitative method of forecasting. So in our previous video, we learned about what is forecasting, and we also look at the ways of forecasting by taking into account the time horizon as a factor of forecasting, and as well looking at the quantitative and the qualitative method of forecasting. But actually, we discussed the qualitative forecasting. So if you haven't watched that video, please do watch the video before you proceed to watch the quantitative method of forecasting. So in today's video, we are going to look at quantitative method of forecasting. So under the quantitative method of forecasting here, we forecast by making use of numbers, or by making use of past data that is available for the organization to use to forecast for the coming period. So under the quantitative method of forecasting, based on this video, we are going to look at two methods of forecasting, and taking into account, these are the two methods we're going to look at. These are the moving averages and then the exponential smoothing. So we have one, moving averages, and then two, we have the exponential smoothing. The exponential smoothing model. The exponential smoothing model. So these are the methods we're going to use, or we're going to discuss under the quantitative method of forecasting within the organization. So under the moving averages, we have two approaches. We have the simple moving average, and we have the weighted moving average. So let's do the discussion further by looking at what is a simple moving average. Hence, I call it SMA, simple moving average. So under the simple moving average of forecasting, that make use of data or past data available to the organization in forecasting for the coming period. Here, all I will do is to find the average of the data that is available to us in forecast for the coming period. Hence, simple moving average. It takes into account the averages of the past data and use that to forecast for the organization. Hence, simple moving average. Okay, so once we get to know that simple moving average takes into account the average, by average, you may want to find the mean of said data that is available, right? So we use the mean, or we sum up those data in terms of their values, and then divide by their number, and we get the average for said data. Once you get the average, that becomes the forecast for the coming period, right? So under simple moving average, we have a formula FT, F subscript T. That means the forecast for the coming period, which should be equal to the actual data for, let's say, week 1, plus the actual data for, let's say, week 2, plus, let's say, the actual data for, let's say, week 3, plus 3 dots, plus, let's say, actual data for T to N, right? So once you get that, we then divide by the number of data that is available in making the forecast. So this is what we call a simple moving average. So let's take note of that. So under the simple moving average, you can clearly see that here we want to actually place in what we call equal weight. And as we take the discussion further, you understand better what weight comes in when it comes to a simple moving average. And mind you, there's a takeaway when it comes to these moving averages, right? So all the moving average actually in forecasting for the coming period take into account the most recent data. They always use the most recent data that is available to the organization to forecast for the coming period. So always take note that in forecasting under the moving average, and it cut across all the method of forecasting, we take into account the most recent data, the most latest data that is available to us in forecast. Remember, if you are asked to solve a problem that has taken place, right, and you have an information available to you, let's say you have just yesterday's information, right, and you have, let's say, 1 month information, which of the information are you going to use to solve the problem? We always believe that the information that is new or latest actually have the potential of helping us to solve the information more better than the information that actually was available in 1 month ago, right? So we believe that the most recent data has more improved information to help to solve the problem better than the information in some month ago. So that's why in the moving or in all the quantitative method of forecasting, we mostly use the most recent data to actually forecast for the coming period. So that's what we need to understand going forward. So that is a simple moving average. It is actually the averages of the past data and then divide by their number, and we are good to go. So the FT is the forecast for the coming period. The A subscript their T in numbers also has to be the actual data in past or the previous data, and N is actually the number of past data you're using to forecast for the coming period. So let's take note of that. So once we are able to get the simple moving average, let's take an example to actually clarify the simple moving average you want to discuss in that line. So illustration 1. The data below shows the weekly demand sales of NY Limited. Determine the forecast for the week using 3-week and 5-week simple moving average for this data. So we're asked to find the forecast using 3-week and 5-week simple moving average for this data. So the 3-week and then the 5-week moving average here, we mean that here for us to forecast for the coming period, we make use of, for example, the 3-week, we make use of 3 data that's in past, right? So we use a 3-week data. So mean that we take into account week 1, week 2, week 3. We use that data to forecast for, say, week 4, right? When it comes to the 5-week data, simple moving average here too, we take into account week 1, week 2, week 3, week 4, week 5, right? And use that to forecast for the next coming period, say week 6. So that's the meaning behind 3-week and 5-week data. So we make use of 3 numbers in the past to forecast for the coming period for week 3, and then for week 5 too, we make use of 5 data, previous past data, to forecast for, say, week 6. So that is the meaning behind that. So here, all I want to do is to create a column for 3-week and then that of 5-week, right? So that's what we're going to do. So in forecast for the 4th week, meaning that we make use of the past data. So the past data is the demand data that you see here. The demand data that you see here, right? These are the actual values that we got, or actual sales that we made from the forecast that we previously made. But we are asked to use 3-week and 5-week simple moving average to forecast for the coming. So the 3-week meaning that we can forecast for, based on this information, we can forecast for week 1, we can forecast for week 2, we can forecast for week 3, but we can only forecast for from week 4 going, right? That's what we can forecast. So we use 3 weeks data to forecast for week 4, and then week 5, week 6, week 7 in that order. But remember, as we discussed, these moving averages or all the quantitative forecast method of forecasting make use of the most recent data. So as we move along, you understand the recent data that we are trying to bring on board. So here, since we want to forecast using a 3-week data, then in forecasting for week 4, we'll make use of the first 3 set of values here, where there's 100, 150, and then 170. So on a simple moving average, we said that, so in forecast for week 4, that should be equal to the actual value for week 1, right, plus week 2 plus week 3. So we're going to have here to 100 plus 150 plus 170, and then divided by 3. That is a simple moving average, right? So always, for you to get the number that will be divisible by the summation of this, it's always going to be based on these parameter they're going to give in. Let's say using a 3-week or a 5-week or any other number you're going to give to you, that's going to be the denominator for that forecast for that coming period. So here, when you add them, what are we getting? 100 plus 150, we are getting 250 plus 170, what are we getting? So here with your calculator, when you add them and divide by 3, you should be able to get the forecast for week 4 to be 140. That's what I got in that line. So you realize that here we can also have the same calculation as 1/3. Then we sum up these values, right? We sum up these values. So here we are getting 250 I don't have my calculator here, so we have here to what? 170. So we have 0 here to 12. Added to this, we are getting what? 4, meaning that we have 420. So we have what? 420 here, right? Okay, and then divide by what? 3. Is that so? Yeah, that is correct. But what I'm trying to put across here is that we can still have this as what? 1 over 3. Okay, saying 100 plus what? 150 plus what? 170. Okay, so here we can see some kind of pattern. Clearly here, you can clearly see that here, this is what is happening. We have 1 over 3 multiplying 100 at the same time, multiplying 150 at the same time, multiplying 170. And that is the same thing as what we adding all this divided by 3. So I was talking about a weight in some few minutes ago, that when it comes to the moving average, we also take into account the weight. So in simple moving averages, equal weights are placed on the previous data to determine what? The forecast for the coming period. And this is the weight that is actually bringing itself here. So you realize that this 3 here can be written as what? 1 over 3 to multiply through this. So we realize that here we are multiplying each value of this past data by what? 1 over 3. So 1 over 3 multiplying 100, 1 over 3 multiplying 150, 1 over 3 multiplying what? 170. I know when you add all, you should be able to get what? 140, right? So this is what we call the weight. So each value here has what? Equal weight placed on it to determine what? The forecast for the coming period. So under the simple moving average, equal weights are placed on the previous or the past data to determine the forecast for the coming period. So let's take note of that. And these weights are always placed on the most recent what? Data. So let's take note of that. So here we have what? 1/4. So week 4, we have the forecast for week 4 to be what? 140. And that is that. Okay. So once that is done, we can also find what the forecast for week 5, week 6, and week 7, right? So let's continue. So for the forecast for that of what? Week 5 to, since we are talking about the most recent data, we are not going to use data that is 4 years what? I said 4 years, 4 weeks ago, because we are talking about a 3-week moving what? Average. So we make use of the most recent data based on what? A 3-week moving what? Average, right? So that is going to be coming from what? That of what? That of what? Week 4, week 3, and then week 2. But these are the most recent what? Data based on the number you are giving here as what? A weight that you're going to what? Place on the past data, right? Which takes into account the most recent what? Data. So in forecasting for week 5, we make use of what? Week 4 data, week 3, and then that of what? Week 2. So in that line, that's what we're going to do. We will say that of week 5 to, we will say that should be equal to what? That should be equal to 120 plus 170 plus what? 150. That is week 2, week 3, week 4, and then divide all by what? 3. So you realize that in a simple moving average, equal weights are placed. But this same thing can also be written as what? 1 over 3 into bracket 120 plus 170 plus what? 150. And we are getting what? The weight, which is what? 1 over 3 being placed on what? This most recent data that we have that is available to the organization. And when you add and divide by 3, you should be able to get the average, the forecast for week 5 to be equal to 146.67, right? And if you want to follow suit to get the rest, so meaning that for week 6 to, for us to find the forecast for week 6 to, we make the most use of data for the most recent data, right? That's going to be from what? Week 5, week 4, and then week 3, because of what? A 3-week moving what? Average, right? We sum them up and then divide by 3, and that you should be able to get what? 156.67, and that of week 7 to, we make use of week 6, week 5, and then week 4. We add them and then divide by 3, and you should be able to get what? 143.33, and that's what's going to follow suit for the week 5 too. So the week 5, we are going to use what? A 5-week information to forecast for what? The next coming week. That should be what? Week 6, right? So we make use of what? Week 1, week 2, week 3, week 4, and week 5. We sum them up and then divide it by 5, and then we get what? week 6 what forecast. So you realize that here the weight is what 1/5. They're going to be placed on what each past data we have here, and that's going to be an equal weight 1/5 multiplying 100 multiplying 150 multiplying 170 multiplying 120 and multiplying what 180, right? When you sum them up, we should be able to get what the forecast for what week 6. And for us to get a forecast for week 7 too, we follow the same thing. Here we are thinking about the most recent data, so here we'll make use of what 120 from week 6, 180, 120, 170, and then 150. So that is from week 2 to what week 6. That will give you what a 5-week what information, right? Add them together and then divide by 5, and you get what the forecast for week 7. So this is how we forecast using these parameters. So always these become the weight for actually the simple moving averages, right? And as we said, the weight, when you add all the weight together, they should be equal to what 1. When you add all the weight together, it should be equal to what 1. And you can give a try. You can see that it's going to be equal to what 1. Okay, so when you add all the weight, we expect that they should be equal to what 1. So let's take note of that. So here, when you forecast for that of, okay, let's go for week 6. So for week 6, you're gonna have week 1 to week 5 information added together and then divided by what 6. So that's going to be 1/6 as the weight. Then we have 100 plus what plus 150 plus 170 plus what again 120 and then 180 plus 120 and plus what 180, right? So there's a weight actually, okay, that we are placing on each of these values, which is an equal weight, right? So when you divide, you should be able to get what 1/4. Sorry, you should be able to get 144 in that line. So let's take note of that. So here for week 6, in using the 5-week data, we have what 144, and when you follow suit to find week 7 too, you have what 150, right? So you can compute that on your own and see whether they are actually true in that line. So this is what we call the simple moving averages, which takes into account equal weight being placed on the past data to determine the forecast for the coming week. So let's take note of that. So once you're able to get the simple moving average, we can as well discuss the weighted moving average. And the weighted moving average is actually the opposite or the brother to the simple moving averages. Whilst the simple moving average actually places what equal weight on the past data or the previous data to determine the forecast for the coming what period, the weighted moving average actually places on unequal weight. So the distinction between the simple moving and the weighted moving average is that simple moving average places what equal weight, okay, equal weight on what the most recent past data that is available in forecasting for the coming period, but the weighted moving average places an unequal weight on the most recent available information in past that is going to be used in forecast for the coming period. And you can clearly see that the simple moving, once it's placed what equal weight, you can clearly see a pattern of what forecast that we can actually achieve our sales level, right? Because you have equal weight being placed on what these most recent past data, but when it comes to the weighted moving average, it doesn't take into account what placing what an equal weight. It places actually an unequal what weight. And in terms of knowing the trend of forecasting, the weighted moving average will fall short, and that becomes a disadvantage of a weighted moving average as against a simple moving average. It doesn't take into account what equal weight being placed on data, but they have unequal weight placed on data. And in terms of knowing the trend of forecasting, it may be difficult to actually identify that. And that becomes what a disadvantage of the weighted moving average. So under the weighted moving average, because it doesn't place an unequal weight on the most recent past data, you're always going to be given what a weight, right? That is going to be used as a parameter to actually calculate for the forecast for the coming week or for the coming weeks in that line. So you're going to make use of this information that we just use to calculate a simple moving average, and using that to calculate what a weighted moving average. In this case here, you're going to be given what various weights for this or what various week data as to calculate the forecast for the coming. So let's take note of that. So using this data to explain the weighted moving average, the data below shows the weekly demand for sales of N&Y Limited. We are asked to determine the forecast for the week using 3-week and 4-week weighted moving average for this data. Okay, so here we have the week and we have the demand and we have the week 3 and then week 4. But note, as I said, when it comes to the weighted moving average, you'll be given a weight that is going to be placed on the most recent data to forecast for the coming period, to forecast for the coming period. So let's see how we do that. So because we have different periods in forecasting, that's why you have different weights for these weeks that we are asked to forecast. So that primarily means that if we are to go for the week 3, meaning they're going to make the most recent data in past using 3 sets of data to forecast for the coming week. And because the weight has been given, always also make use of the weight. The weight will determine the number of data is going to use to forecast for the coming period. And I believe we get that. So here, since for the week 3 we have 3 sets of weight, meaning they're going to make use of 3 data sets to forecast for the coming period. But one thing I also need to note when it comes to the weighted moving average here is that the highest weight is placed on the most recent data. It doesn't take into account whether the most recent data is small or big, right? You just have to place the highest weight on the most recent data to forecast for the coming period. So the highest weight is placed on the most recent data depending on the number of data you are used for the forecast for the coming period. Use the highest weight being placed on the most recent data to forecast for the coming period. So let's take note of that. So let's begin to fill. So since we are using a 3-week weighted moving average for that of week 4, right? That of week 4. The reason why we can't forecast for week 1, week 2, and week 3 here is that we are asked to use a 3-week movie. So when we want to forecast for week 1, we don't have the information that will help us as a 3-week moving information that will help us to forecast for week 1. Likewise, week 2, and likewise week 3. So the only week that we can forecast is to forecast for week 4. Because week 4 we can get a 3-week data that we can use to which is week 3, week 2, and then week 1 to use to forecast for week 4. So let's take note of that. So in forecasting for week 4, here's how week 4 going to be. We have F4, and that should be equal to, when it comes to the weighted moving average, we are going to make use of 3 sets of data. So from week 1 to week 3 to forecast for week 4, okay? And since you have been given a weight, the most highest weight or the greatest weight is going to be placed on the most recent data based on the data we are using here as 3-week data. And the most recent data for this 3 weeks is going to be 170. So we place the highest weight of 0.5 on 170, and it follows still till we are done with placing the weight. So we're going to have here taking 0.5 multiplying 170. And you can clearly see the reason why the weighted moving average actually doesn't follow trend, because you can clearly see that we use week 2 weight to be placed on week 3, and likewise you can clearly see as we move along we use week 3 kind of time in terms of time weight to be placed on week 2, and then even week 1 actually I think for week 1 to just follow it, but others it doesn't actually follow the pattern as compared to the simple moving. So that becomes a disadvantage of the weighted moving average. So we have 0.5 placed on 170 plus 0.3 placed on 150, then plus 0.2 placed on 100, which is actually the week 3 formation. So it doesn't actually follow pattern. So when you do that, that is all in forecasting for that particular week, and you should be able to get you should be able to get 150. That's what I got. You can confirm for me and let's see if that is true. So that is the weighted moving average. So if you also want to forecast for, let's say, week 5, meaning that you're going to make use of a 3-week data that is the most recent, and that's going to be from 150, 170, and then 150, right? So 120, 170, and then 150. We use this information we place the weight on it to forecast for what? Week what? 5. So for week 4, we have the forecast to be what? 150. Okay, and then for week 5 too, that's going to 120, 170, and then 150. But the 120, which is the most recent data, will receive the highest what? Weight. So 0.5 multiplying 120, 0.3 multiplying 170, and 0.2 multiplying what? 150. You sum them up and you get what? Your forecast for week what? 5. So in that line too, I got that to be what? 141. That is what I got for that. And that of week 6 too, you follow the same thing. For us to forecast using a 3-week moving average, right, or weighted, means I'm going to make the most recent data, 3-week what data, and that's going to 180, 120, and then what? 170, right? So the highest or the most recent data will take the highest what? Weight. So 0.5 will multiply what? 180, 0.3 will multiply 120 plus 0.2 multiplying what? 170. And you get a forecast for what? Actually week what? 6. And this is how it goes when it comes to what? The weighted. So we have here to be what? 160. And lastly, you have here to be what? 143. For that of what? The 3-week moving average. So let's take note of that. And that of week 4 too. In forecasting for week 4, mean that I want to forecast for what? Week 5. So here we pick what? The first 4 what? Data that is most recent. We use that to forecast for what? Week 5. Because we have what? A 4 set. And remember, that once we have the weights that we're going to what? Use. So that means they're going to have what? Week 5. We have F5, and that should be equal to. So here we make use of what? The highest weight is going to be receive what? Or the most recent data is going to receive the highest what? Weight in that line. So that's going to be for week 5. We have what? 1. So that's going to be, let's see. So we have what? 0.4. 0.4 being the highest weight placed on what? The most recent data as what? 120 plus 0.3 multiplying what? 170. Okay, plus 0.2 multiplying. So 0.2 will multiply what? That of what? 150. And lastly, 0.1 will multiply what? 100. So when you multiply and sum them up, you should be able to get for week 5 in using a 4-week moving average, you should be able to get what? 139. Week 5 rather, should be able to get what? 139. And when you're able to fill the others to you follow the same logic. And since we make use of what? The most recent, and the most recent data actually receive the highest weight or the greatest weight, you actually place on that. And when you do that, we expect that for us to calculate that of what? Week 6 forecast using a 4 moving weighted average, and that should be equal to what? Week 5, week 4, week 3, and then week 2. But since week 5 data is most recent, that's going to receive the highest weight of what? 0.4. 0.4 in order till you exhaust the weight in terms of placing it or multiplying it in that order. And when you do that, you should be able to fill all the gap by having a week 6 to be what? 157, and then week 7 to be equal to what? 147. So this is how we also would forecast using what? The weighted moving average. Depend on the set of data you're asked to use and the weight that will guide you on how to forecast for the coming period. The most recent data will take the highest weight in that order. So let's take note of that. So let's look at the latter part of the forecasting methods and the quantitative methods, for which the last part should be what? The exponential smoothing model. So that's the latter part we're going to look at under the quantitative method of what? Forecasting. Exponential smoothing model. So we have EXM. That is exponential smoothing model. So another exponential smoothing model also too, all that we need to understand or we need to know is that actually this model have what we call a smoothing constant. A smoothing constant. A smoothing constant. And this smoothing constant is a value that's going to be placed on the difference between the actual value and then the forecast value. So that's what the exponential smoothing model actually does. It actually places a smoothing constant or a value that you'll be given in the question, and then that will going to be placed on the difference between the actual forecast, the actual value, and then the forecast value. When we take the difference between the two, we place that smoothing constant on it, and then at the end of the day, add the forecast for the previous data. So under the exponential smoothing constant, we have a formula. We have t to be equal to, so we say that we have the forecast for the previous period, right, plus the exponential smoothing. Most of the time we use alpha to represent that, and then multiply by the actual value, right, of the past or the previous minus the forecast of the past or the previous data. So we have t minus 1. So always this forecast value must be equal to this in bracket, right? So the forecast for the previous period or the forecast for the immediate past period, compare that to the actual value for the immediate past period, and then you place a smoothing constant on it, you add to this, and you get the forecast for the coming period. So let's take note of that. So this is actually the exponential smoothing model. It actually have a constant value being placed on the difference between the actual and then the forecast value to get your forecast in that line. So let's take an example to actually explain this. So use the same example used to calculate for the weighted moving average to also to work out for the exponential smoothing. But here we're given exponential or smoothing constant to actually use in that line. So let's take note of that. So this is an example to illustrate the exponential smoothing model, right? So the data below shows the weekly demand sales of NNY Limited. We are asked to determine the forecast for the week using an exponential smoothing constant value of 0.3. So here we want to forecast for this from week. Okay, so here taking into account from week 2 to week 7. So we want to forecast for week 2 to week 7. So that's what we have been given with an exponential smoothing constant of 0.3. So this is what we're going to do. Since we know the formula for forecast, using exponential smoothing ft to be equal to the forecast for the previous period plus the exponential smoothing constant multiplying the actual value minus the forecast value, right? Okay, so let's take note of that. So here, for us to forecast for week 1, we realize that week 1, we don't have any immediate past data for us to forecast. So in such situation, we will make assumption that you assume that your D1 should be equal to F1. By that way, you tell us that let your actual demand or actual value for the sales should be equal to the forecast in that line, forecast for that week in that line. So in a case where you don't have a previous period and the exponential smoothing model to forecast for, let's say, for the first week, then you make assumption that let week 1 sales or demand should be equal to F1, right? So you make that assumption, you state it so that you know that that's what you are trying to say. So meaning that D1 here should be equal to F1 here. So that's going to be sorry, here it is 2 to 7, and that should be 0.3, 2 to 7. So it should be equal to 100. So mean that D1 is equal to F1. Okay, so let's take note of that. So once we know the forecast for the previous for week 1 and demand for week 2, we can forecast for week 2. So that's going to be F2, and that should be equal to F1 plus exponential smoothing. We have A1 minus F1. Okay, so what are we getting? The actual value is the same as the demand that we use in that line. So let's take note. So F1 was 100, and we know that our exponential smoothing was 0.3. So 0.3, okay, 0.3 multiplying what? So what was our actual 100? What was our forecast 100? So what are we getting at the end of the day? We are still getting 100. Because here is going to give you 0, 0 multiplying 0.30. So plus 100, we are getting 100. So mean that for week 2, our forecast values was still what? 100. Let's go for what? Week 3. So that of week 3 2, you follow the same what? Logic. So you have what? Week 3, that's F3 forecast. That's going to the forecast for week 2 plus our exponential smoothing. You have actual for week 2, then the forecast for what? Week 2. Okay, so what are we getting? So we have the forecast for week 2 to be what? 100, right? Plus 0.3. What was the actual forecast for week 2? And that is what? That is 150. And our forecast for week 2, which is what? 100. So what are we getting in that line? With that, I had 115. So you can confirm that and let's see if that is actually true. So that's what I got. So that's week 3, 115. So for us to get also that of week 4 forecast 2, that's going to be what? That of week 3 forecast plus the exponential 0.3 and take the difference between what? Week 3 and then the forecast for week 3. And we are good to go. For us to get that of what? Week 5 2, it is what? That of the forecast for week 4 plus the exponential smoothing, multiplying the difference between the actual value for what? Week 4 and that of the forecast for week 4. That will help us to find what? The forecast for what? Week 5 in that line. So you exhaust what? The list. So here, the week 4 should be equal to what? 131.50. That's what I was getting with my calculator. And here too, I was getting 128.05. And then week 6, I was getting what? 143.635. And then lastly, week 7, I was getting what? 139.545. In 3 decimal places, that's what I was getting in that line. So this is how we also use the exponential smoothing constant to actually calculate. So for us to calculate for a forecast for that of a particular week, we make use of the most past immediate what, or the next previous data that comes before the forecast what value one, or the forecast period want to what, know its value, right? So we make use of for the immediate what, past recent data to forecast. So if you want to forecast for, let's say, week 5, that's going to be what? Week 4 plus the exponential smoothing constant to bracket actual value for week 4 minus the forecast value for week 4. And you forecast for what? Week 5. So let's take note of that. And this is where we bring an end to section 2 or part 2 of what? Our discussion on forecasting. So in our next video, we will consider by looking at what? How to determine forecast error and then know how to calculate forecast error to help us to make decisions based on the prediction that we make for the future for the business in that line. So thank you so much for watching this video. It was really helpful to please do well to subscribe, like, and share. I'll see you in the next video. Bye-bye.